Assalamu alaikum wa rahmatullah, dear students. Today, inshallah, we're going to talk about chapter 9, which summarizes IP subnetting. So this chapter is divided into three major sections. The first section summarizes the subnetting in IP address version 4 networks, and in that section we will talk about network segmentation and what are the fundamentals for subnetting and how we can calculate the subnet network address, the subnet mask, and how to design the subnets inside a network. In section 2, we'll talk about the addressing schemes, where we try to discuss the structure design and how can we take into consideration the different types of devices, whether our devices are clients or servers or peripherals like printers and so on, and how can we take that into consideration during the network subnetting. Then in the third section, we'll talk about the design considerations for IP address version 6, and in that section we'll talk about the major differences in terms of the subnetting methodology for IP address version 6 versus IP address version 4. So to start, first, we'll talk about the reason for subnetting. As we all know, in the early network implementations, the main characteristic for the network design was based on the fact that there is one or very few public IP addresses that are assigned to the network. So, in which case, we have one flat network that has all the devices, and all these devices are connected to one router, as we can see here. Problem with that flat design is the fact that for the case of broadcast traffic, all the traffic is actually circulating amongst the network, creating significant overhead that can slow down your traffic in the network. So instead, designers later on tried to use the concept of segmentation to divide the network into sub-networks, and each sub-network is equivalent to an individual network, where a sub-network is connected to a router, and the group of routers are connected together into the major enterprise or the major company router, and this router is connected to the service provider. So the subnetting is the process or the procedure for designing or planning your subnets inside your network to divide the flat network into subnetworks. To communicate between networks, you have two or more of these networks that can communicate through the default gateway on each network. So subnets talks about the fact that your network, like network 1 here, can be subdivided into two subnetworks. Each of these subnetworks will have a separate, what we call subnet address. So subnet address 1, subnet address 2, and so on. So each of these subnets can now be segmented and isolated from each other, so that the communication between the devices inside the subnet will not actually go through the other subnet. And at the same time, if you want to communicate between the subnet and the other network, it works the exact same way like communicating between networks, where the traffic has to go to the default gateway and then it goes to the other network. So subnetworks work the same way like a separate network, where they have a separate subnet address, and in that case they can use that subnet address to communicate with other subnets or with other networks on the internet. To design the subnets inside the network, we have to take into consideration some factors like what are the needs for each subnetwork. For example, a subnetwork can cover a lab in a university, or an office in an organization or a company. So the division or the segmentation of the network into subnets should take into consideration the needs and the requirements for this subnet, whether we need how many devices, how many peripherals or facilities like a printer and so on, and also how to take into consideration the future growth of this subnet in terms of the expected need in the future. All these factors have to be taken into consideration through an extensive study for these requirements for each subnet. And then based on these requirements, we divide or we segment our network into subnets, and then we design the address for each subnet. And then each subnet will be able to accommodate a certain number of devices, as we will see later. One of the common methods for designing the subnets or the benefits for designing the subnets is the ability to be able to reuse some of the IP addresses inside each of these subnets using the concept of private IP address. As we have discussed before, the private IP address may be actually reused between all these subnets, in which case this subnet may actually use private IP address like 10.0.0.0/8, and also this one can use the same range of IP address, in which case we can reuse these addresses, and when these subnets communicate, they have to use the router, which uses a public IP address to reach to the internet. So as we can recall, the range of private IP addresses are summarized as here. So we have the 10.0.0.0 with a subnet mask of 255.0.0.0, and we also have 172.16.0.0 with a subnet mask of 255.240.0.0, and we also have a third range of private IP address, which is 192.168.0.0 with a subnet mask of 255.255.0.0. So all these ranges can be considered and reused between the subnets, in which case, depending on the requirements and the needs for each subnet, the designer or the network planner can use one of these ranges of private IP address and assign these addresses accordingly to the different devices. So some factors that we take into consideration while designing the subnets is the fact that printers and servers, they will be assigned a static IP address. As we have learned before, servers and printers, they have to be accessible from the internet, in which case they have to be assigned a public IP address, and this public IP address has to be assigned statically so that the servers can be accessible on the internet. Other users and clients can be assigned a dynamic range of IP addresses by connecting to the DHCP servers using typically a subnet prefix of /24. Routers and other network devices can be assigned the first available host addresses in the range of subnets. So if you have a subnet of, for example, 192.168.1.0/24, then the router interface in that subnet will be assigned 192.168.1.1 as the first available host address to refer to the router interface.